Quantitative Big Imaging, Lecture 10, Visualizing Your Data. This is the second part of today's lecture, and it's going to go into more technical, practical parts about the endpoint of what you're working with your data, how to present the results. And for this, we, as usual, need a bunch of modules. And the important thing here is now we are going to look into, for example, Seaborn features. We are going to look into matplotlib features, and also a different package called plot9. And once you have done your whole quantitative analysis, you also want to show the world what you have done. And how to present your results is actually how to bring out the message of what you have learned. So the question is, you have to select which is the target of what you want to show. Because you can show a completely different type of results and plots if you discuss it with a colleague or maybe with your supervisor or your student or something. Then you can have very detailed plots of a technical level that essentially no one else than you and your colleague understand. If you start to want to present it to a greater audience, then you have to reduce a lot. You have to think about font sizes to make sure that people can see it on the last row in the room, etc. Going further on to the publication, then it really needs to be a very clear distinct presentation of the data, minimized to only show what you really want to show. And finally, also web pages in principle has the same limitations as the publication, maybe even more, because you often don't have the caption underneath the figure, and you also may not have so much space for text on your web page. So there you really have to have the very sharp highlight of the result. So visualization is actually one of the biggest problems in this big sciences, and that is the task to visualize a lot of heterogeneous data. Tables, naturally, are very difficult to interpret, and 3D visualizations or higher dimensional visualizations are very difficult to compare visually, and it's often very hard to divide and split the data to look in a way that you can see trends and find problems. So you have to decide on the purpose of your visualization, and there are two main kinds of visualizations. One is understanding and exploration. For that, you have a very small and known audience, you and your colleagues, and both, or the whole you and your audience, have a pretty high degree of understanding of the specific topics that you are looking into. If you go beyond this closed circle and want to present your results, then you have a very much wider and sometimes unknown audience. Could be a reader of a paper, could be people listening to a presentation, and there you can at most expect a general understanding of the topic you're presenting. And here is a graph from the book by Knaflick, and it actually gives you a pretty good idea. So if you have a live presentation, you have a lot of control. You can interact with your audience, and then you don't need a high level of detail. But as soon as you have a written document or email, then you lose your whole control, and then you have to describe what you're doing in a good way. It has to be clear what the plot is saying. So here you need also a higher level of detail, at least in the description of what you're showing. Not saying that you should fill it with a lot of clutter, small details, because also small fonts in a publication is very hard to read and interpret. So be very aware what you put in a written document. Then of course there is the problem of bad graphs. So there are way too many graphs that say my data is very complicated. I'm so good. I know how to use XYZ toolbox in Python, MATLAB, R, Mathematica, whatever. Also a problem is that most programs by default deliver quite poor plots, and it's a lot of work to produce good visualizations. And XKCD illustrates this with the point in the mid-90s when people started to use PowerPoint and MS Paint to produce their graphics, and I have seen so bad examples from this time period. And the difference was that before this there were technical drawers who illustrated the publications, and then all of a sudden it was left to each author to do their presentation of the data or the illustrations of the data. And that is where we went down into this valley. So really be very careful about how you put your data together. It will take time if you want good graphs, good and understandable graphs. So some bad examples. You could, for example, see things like this. This scatter plot doesn't show much of the data. You can see an indication that there is something on the top, but the remaining magenta rings in the dataset, they are hidden behind all the trees in the forest. Another one is when you have this kind of plots, again a scatter plot, but now you see some scattering response curve. And in the beginning there is a good separation, or decent separation at least, but at some point there is not much information left, and then you don't see anything. It's just a full clutter, everything. Then we come to this kind of connectivity graphs. Already here it's difficult, but if it grows, it's really impossible to see any trend in this data. So here people really have to think about how to present their data. So how to improve? First of all, you have to identify your key ideas. What do you want to present in your plot? What is your message? And next point, is this message really clearly communicated? And then the last question, is this plot necessary at all? Because if it's not really necessary to support your conclusions and discussions, why is it there? That are important questions that you have to ask yourself, and you can even think of the idea that every drawn line is expensive, and try to reduce it to a level that it really makes sense. And on this, there is at least 2 pieces of literature that you can look at. This book by Knaflit is easy read, so I would recommend at least browsing through it. And this one puts the question, if all data visualization have to be beautiful, and there you can ask yourself and read this and reflect on that. So some simple rules. Never use 3D graphic if it can be avoided, unless you want to be deliberately misleading. A good example is this one, where you have cones instead of bars in a bar chart. The question is here, does the cone represent just the level, or is it the volume of the cone? And that is really confusing if you see this kind of plot. The cone doesn't bring any information, it's just disturbing and misleading. Pie charts can be good, but they have to be used in cases when it really makes sense. Otherwise, they can be very hard to interpret. The background color should almost always be white and definitely not light gray. This looks just ugly. And then color palettes should be adapted so to the human visibility sensitivity. You can even think about having color maps which are adapted for colorblind people. And of course, a combination of colors and transparency can actually also bring quite a lot in the presentation of your data. There are even theoretical rules how to present your data, and then we come into a topic of the grammar of graphics. The definition of grammar is a set of rules for constructing and validating a sentence. And of course, there are also specific rules and relationships how the different words are combined together in a way that makes sense. So this has also been extrapolated into the topic of grammar. So there is this book, Grammar of Graphics, that introduces the idea of breaking down visualization into specific components. And here we can see as that normally a plot is just something that is a plot command where you put the data in and it produces a picture. In Excel, you would select a range and click select the plot type and click make, and then you get something. In MATLAB, you would do just run the plot command, maybe add some color or shape, and that produces everything. And there is no way to come from the idea of some grammar. So if you spoke by finding entire sentences like in a book, this would be ineffective. So instead, it's much better to build it up, these graphical visualization, word by word. And this is the idea which is now introduced. So let's say we have this plot. It's already separated in a nice way. Looking at it, we have a data mapping. So we have different variables. Variable 1 goes to X. Yeah, that's somehow lost, but its variable 2 goes to Y. That is the data. And then we come to the points. We have different points here, and there are even regions that the lower part has the orange color and the upper region has the blue color. Then the next component are the axis and coordinates. So we have here and this different X and Y axis, and you can see there is a grid net. And finally, as the last piece, we have also the labels and annotations. We have axis labels, we have a title, we have also a legend, and all that is built together as a sum and produces this nice plot in the end. And then we have different decorations. You can have, for the plots, you can have a curve legend that you should actually have, telling what each curve represents. You have axis labels telling the information you have on each axis. And of course, there should probably also be a figure title. That depends a little bit on the context where you use it. In some cases you don't want it, but let's say we want the figure title on it. And in particular, if you use multiple plots in the same figure. Then if you have images, you should have a color bar to tell how the different levels or colors are mapped to the values in the measured data. And a thing that is very often forgotten is that you should also have a scale bar that tell the size of the objects that you have in the image. Otherwise, it could be anything. This could, however, also be handled by axis labeling. So you could have the axis ticks and give them in the unit of, say, millimeters, and that would also be okay. The color maps is a science of its own, and choosing the right one is not trivial. And this flowchart tells a little bit the decision sequence, how you go into selecting how you want to present your data. And more about this you can read in this publication. And yeah, you come to different types here. You have continuous data, discrete data, and categorical data. If you have a continuous or discrete, then you can go into, say, which kind of color map you want to have for the background color or not. And then you can also select if you want to have a dark way, or you want to have something where the bright part is in the middle, and so on, so on. So there are a lot of guidelines in this publication that you can look at. So let's go into an example. So let's ask, what is my message? And now we want to show the results. So the question is, how do we go beyond just showing the result or get a feeling? Because that is usually not sufficient, particularly not for a publication. But here we use the package plot9, which was originally from the ggplot in R, but it has been ported to Python. And the interesting thing with this is that you build up your plot as actually a sum of different components. So here we have our data label, data connection, and on top of that we have the geometry of the points. And yeah, in this case, just some random data that we bring together in a data frame. So what we can do, and we could, for example, focus on a single simple message, like X is a little bit correlated with Y. We can get some trend line in, and we can get some error bands on the fit. And this is now shown, and again with the ggplot, where we have points, we have some smoothing, and we also add a title to the figure, and the theme is just telling that it's how the color coding should be of this. And this gives this nice plot, which is a bit better than the previous one, which we just had a point cloud, which doesn't tell much. We can visually tell something, but already here we got some more trend information, and also some information about the spread and how well the fit was. We could also go into the problem when we have too much data. So this is the new randomization. We see that the data is more sparse here than in the middle. And the question is how to bring more, so to tell more about what is happening here, because it's just black, so we can't really tell much about it. So let's reduce it a bit. So the first thing is that we do some local binning. Instead of showing every point, we just bin up into blocks like this, and then we have a little bit of a color coding, and we can see really already a little bit of intensity variations within the data set. That is less data here than in the middle. We also got the trend line that could be useful or not useful. I don't know really with this kind of data if that really makes sense, but we can do so. We also got the color bar on the side, which could be relevant. Really heavy reduction we can do if we just add this kind of trend lines isolines. Again, with the isolines, we can again see that there is an intensity concentration towards the middle around here. This, in my opinion, would probably be a little bit too much reduced, but for some purposes it may be good. If you want to go deeper into different visualization packages, there are plenty. Just for Python, there is the matplotlib. It's actually a pretty good help. It's matplotlib cookbook, which you can find at the ETH library, and the code examples are on GitHub. Plotly is another very popular plotting library, which gives also the possibility to have interactive plots. Seaborn we have already used, and now we looked into also ggplot, and there is a nice overview of all these packages on this location. So there are many ways to do it, and actually this book I found before I got access to LLMs and AI help. Meanwhile, I actually honestly go to the chat and ask for specific things, and I get good suggestions on how I should solve different visualization tasks. Could be how to bring in extra axes or something, and the chat gives a more direct answer often than if you would search around on different places on the web. And that concludes this part of the lecture. And we've talked about how to visualize the data, and of course there are many toolboxes to use, and you have to choose the one that fits your needs.